right, you guys, so this is notes on scientific method. The reason why we're doing this flipped is because you guys have done this before. You guys know the scientific method, so it's just going to be a slight brief overview. You need to take notes on this. I will be checking notes in your notebook for scientific method. So all it is a plan for scientists. It gives them guidelines. Science is all over the world. All scientists use this guidelines so that they can reproduce their information. So it's just a plan scientists use to solve problems. They look at things that are around them and how do they solve them. So the first part, this is the scientific method. Notice it's in a circle. It is never ending. Even though you think you maybe solved a problem, people can go test it out, see does it actually follow it. Right? So it's always in a circle. It's never ending. There's not a start and a stop. Okay. And another thing to remember is you can, if you all of a sudden, you're in the middle of your experiment and you realize it's not working, you can go back to your problem. Okay. You can go back to your hypothesis. So it can go both ways. Okay. So the first one that we're going to look at is the problem. All right. This is a clear statement of what is to be studied. So what are you looking at? Okay. Again, state as a question, and the problem should also be testable. We don't want to just throw a question out there willy-nilly. It has to be something that we can test. All right. And most of the times it happens because of things that are noticed. Why are things happening the way they are? Okay. So it's observations. You usually see something that's going on, and you want to, wonder why. Okay. So stated as a question is a big thing and testable. All right. After you have that problem, you have to collect information. This could also be called research, depending on where you're reading. But you want to get that background information. All right. That will help you develop your hypothesis. It will also help you develop your experiment. Okay, so this part is very important. When we do our labs, it tends to be background information that I give you. But if you are working in a lab in college, because you can make some sweet money doing it, you will have to look at other people's lab reports. What have people done in the past, and how are you going to change that? Okay. So we'll also make observations. Write down all the things that you see. All right. Write down data that has been collected. All right. So background information. Look at other lab reports, experiments that people have done. Okay. After that information has been collected, you want to state your hypothesis. Now, this is an answer to your problem. Okay. It doesn't have to be correct. Okay. Your hypothesis later on, you can go back and state it was not correct. Right. But this answer should be based on information that you already collected. All right, previous experiments, observations, things that have done in the past. You should not just pull a hypothesis out of thin air. Right? You have to base it on other problems. Okay, base that answer on other experiments, observations, things like that. Okay. After that hypothesis, you would develop an experiment. So it's going to test the hypothesis. In the experiment section, you definitely want to, make the directions and list everything that you're using so that somebody else later down the road can repeat that experiment. Right? That is a huge thing with science is other people want to try it out. What did you do? Can they copy your experiments? That's why whenever you guys are writing out an experiment, I'm going to have you have to be detailed. All right. Notice when I write your labs, it's detailed. Otherwise, you're like, what's happening? Okay. You should make sure that you don't have multiple variables that are changing. Okay. Whenever you make a observation or write up an experiment, you should definitely just have one variable that changes. Okay. What type of data are you collecting? That always should be thought about when you are going through the experiment. Okay, when you're writing up that procedure, what are you collecting? How am I going to organize it? Am I putting in a table? Am I just making qualitative observations? Am I just writing down color changes, things like that? How am I going to relay that information in a systematic way. Okay. Once you have that data, you want to analyze it. Okay, so am I going to take that data and put it into a graph so I can see patterns? Am I going to take that data and do calculations? Okay, this is where you take that conclusion part of it, drawing out, does this data support the hypothesis? This is where you're looking at that data. Okay, you say yes or no, does it support my hypothesis? Okay. All right. The last part is communicating results. This is where you take that analysis and you're putting it into words. You're sharing it, what you discovered, with other people. Now, in here, you're going to share it with your classmates. You're going to share it with me, things like that. But you, if you are a scientist, you might then publish your results. You might go to a conference and share it with other scientists. Right? Tell them what you found. Okay. The last part, there's theories, law, thing like that, but we're going to focus on theory. It's just a widely accepted hypothesis. All right, so it can change. All right, later on it can change, but it's been tested many times, and it's accepted. That hypothesis has been accepted. Okay, so that is the scientific method. Okay, it's really brief. You can go back and watch the video again if you need to, but it is. You've seen this before, okay? You've seen those steps before. And we're going to actually look at how does this fit into an actual lab report in class. Right? Let me know if you have any questions.